Today I'm going to explain how to use the Fick principle in calculations. So the Fick principle states that VO2, the volume of oxygen consumed, is equal to blood delivery in the form of cardiac output times oxygen extraction in terms of the VO2 difference. So how much oxygen my body can use will be a function of how fast it's delivered in cardiac output and how much I actually use in terms of the muscle. So the difference between the amount of oxygen in the artery compared to the vein is an indication of how much actually enters the tissue. So as a review, cardiac output Q is the amount of blood pumped in the heart in 1 minute and represents oxygen delivery. And VO2 difference is the difference in the amount of oxygen in the arterial compared to the venous blood and represents how much was extracted and used by the muscle. So one of the first things we have to talk about when we're using this equation is units, standard units. So the standard unit that we express VO2 in is liters of oxygen per minute, which is an absolute value. We also can express VO2 in relative terms, but we won't use that with the Fick equation. Cardiac output is usually expressed in liters of blood delivered per minute. And our VO2 difference sometimes is expressed in mils of oxygen per 100 mils of blood or mils of oxygen per liter of blood. It really depends. So 15 mils of oxygen per 100 mils of blood is the same as 150 mils of oxygen per liters of blood. And it's really important to note how your units are expressed. You can't just automatically go put in cardiac output times VO2 difference, especially if the units don't match up. And I'll give you an example of how not to do it later on. So if we take our equation and if we plug in cardiac output measured in liters of blood per minute and multiply it by the VO2 difference in mils of oxygen per liter of blood, obviously our liters of blood units would cancel out here and we'd be left with mils of oxygen per minute. This is not a standard by which VO2 is usually expressed. VO2 is usually expressed in absolute terms of liters per minute or in relative terms of mils per kilogram per minute. So if we wanted to express it in terms of absolute, we have to convert this mils of oxygen per minute to liters per minute. And if we want to convert it in terms of a relative value, we must divide by body mass. Let's do an example. If we want to figure out what a resting absolute VO2 is in liters per minute, we know that an average male's resting cardiac output is about 5 liters per minute, and that an average VO2 difference is 5 mils of oxygen per 100 mils of blood. These are pretty standard. So let's do a derivative to figure out resting VO2. I'm going to start off with how to do it wrong. Some of us might automatically go, let's just multiply the cardiac output times VO2 difference and hopefully we'll get a VO2 value. But I'm going to show you how you can potentially make a bit of a whoopsies by doing it this way. So if I took 5 liters of blood per minute and multiplied it by 5 mils of oxygen per 100 mils of blood, there's absolutely nothing here that can cancel it. So in terms of unit canceling out, this will not work out. So I would end up with 25 liters of blood, mils of oxygen per minute, 100 mils, whatever. So I'm going to show you how to actually do this correctly. So we're going to fix this. So we're not going to express the cardiac output in terms of liters of blood per minute. We're going to convert that to mils of blood per minute. So to do this, maybe some of you automatically can do this, but I'll just show you quickly using unit conversions. I'm going to take my cardiac output expressed in liters per minute, and I'm going to convert it by putting liters of blood on the denominator so that it will cancel out the liters of blood on the numerator here and mils of blood up on the numerator. So there's 1,000 mils of blood in 1 liter of blood. Liters of blood gets to cancel out. And I'm left with 5,000 mils of blood per minute in terms of my cardiac output. So if I substitute this in here and I multiply my cardiac output now expressed in mils of blood per minute by my VO2 difference of 5 mils of oxygen per 100 mils of blood, the units will now cancel out. and I'm left with 250 mils of oxygen per minute. However, the standard by which we express VO2 is not in mils of oxygen per minute, it's in liters of oxygen per minute. So I now need to convert this. So if I take 250 mils of oxygen per minute, I need to cancel out my mils of oxygen, so it goes on the denominator because it's on the numerator here. And I'm going to express it in liters of oxygen. I know there's 1,000 milliliters in 1 liter. My units cancel out. If I take 250 and divide by 1,000, I'm left with 0.25 liters of oxygen per minute.